All right, quick review because this is important. You're going to see it probably on a quiz or a test. Oh, hey, Quiz Thursday. Oh.
Quiz Thursday. You got another
Quiz Thursday. What is it, Bible quiz?
Yeah.
You always have a Bible quiz. That's no...
Not on Thursdays, though.
Did you what?
Thursday is the new Friday.
Thursday's the
Ew.
26 as well? Or
You did that wrong assignment. Where'd you get that from?
I don't know.
Wait, let me see. No,
No.
that's the right assignment.
Okay,
You're
that
right.
is.
Yep, that's right.
Okay.
Yep.
So I didn't, no, like, but then it says 26 also.
This is for today.
This is for today. So I think I did the wrong number.
No.
Or we fixed it.
I don't know.
What?
Yeah, so did everybody else. So,
Okay. So I was right.
yeah, I don't know why that is what it is.
Oh, did we have that?
Maybe I
Oh,
had
what?
it again. I don't know.
And
It's
what?
kinda goofy.
Kramer, open what?
What?
Of
Notation
NO.
to identify isotopes of it.
And in this.
Oh, I must have just forgot to finish that.
And
Well,
maybe
you gotta get today's homework again?
Yes.
Oh.
Ethan.
I'll get it later.
Alright.
Get it in.
Almost all the mass of an atom is in the...
Nucleus. Let's just review a few.
oh, I think
Mass number is the number of...
Protons.
Neutrons.
Sorry. Protons. Number 4.
Okay, someone thinks it's 4, someone thinks it's 2. Raise your hand if you think it's 1. Raise your hand if you think it's 2. Raise your hand if you think it's 3. Raise your hand if you think it's 4. Okay, it's 4.
Oh, I was going to say, oh no.
Oh, no, probably two.
Atomic number. Raise your hand if you think it's 1. Raise your hand if you think it's 2. Raise your hand if you think it's 3. Raise your hand if you think it's 4.
Oh,
Yeah.
Okay, so we have some vocab here, words here that are very important. Before we get into this, let's review. We have atomic number. What does that tell you?
Number of protons.
Number of protons. Okay? And the number of protons determine what?
What element it is.
And you could also say that if you know the number of protons, you also know something else very important.
The number of electrons.
The number of electrons. And then why does it also tell you the number of electrons? What was that? Because an atom is neutral, so therefore you better have the same amount of positive things as you have negative things. Okay, and then we have mass number, which we said was what?
Number representing the sum of protons and neutrons in the nucleus of the atom.
Okay, so it's protons plus neutrons, the sum of them. Okay? So you could say, or the nucleons. Now, this is just review. You don't necessarily have to put it in, but it wouldn't be bad if you did. Now, let's also then review this. Let's say I know that iron, which is Fe, has a mass number of 40. I want you to tell me how many protons, electrons, and neutrons it has. Just a quick review here. Quiz is going to have stuff about your people and your models. It's going to have stuff about atomic number, mass number. It's going to have stuff about this. It's probably going to have stuff about what we're going to do tomorrow. We at least attempted?
Yes.
Okay. Who thinks I'm pretty sure I'm right? 3? 3 people are pretty sure they're right? Nobody else? They're not so sure? Mari, not confident? Okay. Well, you should be very confident about this one, I hope. Why should you be very confident about that one?
Because iron always has a certain number of protons.
Because protons determine what?
The identity.
The identity. And its identity is iron, right? Okay? So how would you find the identity of iron? Periodic table. What does its protons tell you? Well, then shouldn't you also be pretty sure about this one as well?
My numbers are off.
Better have the same amount of positive things if I have negative things? This one's probably the hardest, but if you know this well, it's not so hard. Okay? We have this, which is protons and neutrons, and we have this, which is protons. Shouldn't we be able to figure out the amount of neutrons with those two things? What would it be? 14.
Yay.
Numbers are off.
Now I realize that's a low amount of neutrons, but I just made it up. I don't know if this probably doesn't exist. But, okay, just wanted to give you a quick example. Yes?
Why is iron symbol Fe?
Because Latin, because there's already a symbol I, and there's already a symbol IR, I think. Yeah, there's an IR, and there's an I, so I think it probably has to do with this Latin name. Yep. That's a great question, though. Not enough letters in the alphabet to count for all of these elements of the periodic table. All right. Okay, being able to do that, being able to know the difference between atomic number, mass number, and how to apply it to the context of an atom is very important. All right. So, if you remember, another review here. Who discovered the neutrons? One of 8, right? He discovered the electrons. Chadwick. Okay?
Oh, it says it right there.
Now, if you look, what this is trying to show you is here are 2 oxygen atoms. One has a mass number of 16, one has a mass number of 18. Obviously the one that has a mass number of 18 weighs more because it appears to have more what? Neutrons. Why do I not say more protons? That would change the identity. They're oxygen. They have to have how many protons? 8. So if this has 8 protons, how many neutrons does it have? 8. If this has 8 protons, how many neutrons does it have? 10. And that's where we were talking about when they discovered the neutrons, Chadwick, they were trying to figure out how much they bent when they put it in an electric field. Okay, this is kind of how they also identified the concept of an isotope. here. Okay, hopefully as you were writing, you were kind of reading, or at least trying to process this in your brain. What's an isotope? Without just retelling the definition. What's an isotope? Ethan? Yes. So he said it's an atom of the same element. The only thing that's different between those particular things is the number of what? Neutrons. Okay? Just like I showed you on the previous slide, same atoms or same element, both oxygen, right? Okay? But they have different numbers of what? Neutrons. Okay? And so therefore they weigh a little bit differently. And that comes into play when you guys probably get to a higher level. We probably won't get too crazy into that at this point. But an isotope is really just the same kind of element, but how atoms of that same element could have different number of neutrons. I could have an oxygen atom that has 10 neutrons. I could have an oxygen atom that has 9 neutrons. I could have an oxygen atom that has 8 neutrons. Okay? Alright, so what this is showing you don't have to put this in. What this is showing you is that naturally occurring in nature, anybody know what this element is? Nickel. Okay? Naturally occurring in nature, most of nickel that naturally occurs in nature is in this isotope form. 68% of nickels naturally occurring in nature is going to be of that isotope form. Okay, how many protons does nickel have up there? 28. So then how many neutrons does the most naturally occurring nickel form have? 30. Everyone see it? But do you see how there are some other forms as well? Okay, that actually is important when you get to a higher level when we start talking about atomic mass on a deeper level, because when you pick one nickel atom out of a group of nickel atoms, how do you know which kind you get? You don't, right? Like, if you randomly pick a jelly bean out of a big bag of jelly beans, are you going to be able to predict which color you get? No. Well, you can see which color you get, but can you see which kind you get of an atom? No, you can't see the atoms. Okay? So believe it or not, they have to do something to account for how to weigh these guys when all of them weigh different amounts. But we won't talk about that in this class. All right, isotopes differ in the number of? Neutrons. That one should be a quick, easy one. Number of neutrons. Everything else is the same. All right, so let's do isotopic notation. This is the new thing for today. It's a way to show isotopes. So you see that things are starting to build. Are you going to be able to do isotopic notation if you don't know what mass number or atomic number is? Okay. So, quick review. Atomic number is what? The number of protons, and it determines the identity. Mass number is? Number of protons and neutrons, or the number of nucleons. Alright, so let me show you how you do this. Why don't you guys put this in, and then we will talk about it. Got it? Ready? It's really quite simple here. Here's how I do isotopic notation. Okay, if I give you the name of the element, you just start with its symbol. So this is beryllium. You would identify that beryllium symbol is Be. That's where you would start. Okay? Now, they would have to give you the mass number. So for example, I could go beryllium and then go 9. That's always the mass number if it's in that form. I want to put that somewhere near it. Okay, if they give you some form like that, that after the hyphen or the dash is always the mass number. If they give you that, you have all the necessary material you need to write it in isotopic notation. Because the name beryllium will tell you the what? The symbol, right? Okay? You already know the mass number, and if you know the name, you should also then know the what? Atomic number, because protons determine identity. And they would say this is a leading superscript, and this is a leading subscript. Subscript, sub, below. I'm not sure why super is above. Superman? I don't know. And leading just means comes before. Alright, so if I gave you this isotopic notation, could you tell me protons, electrons, and neutrons fairly easily? Protons would be what? 4. Electrons should be 4. Neutrons should be 5. There it is. Okay? Before we do this, I'm going to give you another example that I want you to do. So let's say I have a calcium isotope, let's say that guy. Write that in isotopic notation, please. Yes, Everett?
Calcium, Ca.
Yes, sir. Yep. Calcium and Ca. Your element code coming next chapter. We're almost done with this chapter, believe it or not. I told you there was a quiz Thursday, right? Yeah, I think we'll be done with the material for this chapter tomorrow, actually. Smaller chapter. You got an answer, Shane? You don't have to tell me. You think you're getting it?
Thinking.
Okay. Rose, think you got it? Sid? Derek? Alright, everybody should have identified that your symbol is what? Okay, then there's a number here and a number here. We got to figure out where the numbers go. By definition, mass number always goes on top. Notice, they gave it to us, didn't they? Yeah? Okay, and what number always goes on bottom? Atomic number, which that is the number of protons. This is the number of the identity of the atom, so you can just look where?
Here.
And what does it say?
20.
You guys get that?
Yeah.
Alright, protons, electrons, neutrons, tell me.
Yeah. 20, 20, 26.
Alright, you guys are getting it.
Yeah.
20, 20, 26. 20 protons, because that's the atomic number. 20 electrons, because it has to be a neutral atom. 26 neutrons, because you know the definition of the mass number. Now notice, if you ever have a smaller number on top than you have on bottom, you've done something wrong. Because by definition, protons and neutrons should always be more than just the protons. You can't have negative neutrons. Huh? I think we're doing well. That's good. That's very good. Whoopsies. I didn't turn this back on first. Atomic mass. Last thing for today. So we have, just to make you guys aware, we got 3 vocab words that are very similar. Okay. You got 3 vocab words that are just the 3 same words mixed around.
Atomic motor mass number, atomic mass. Wow, they should do atomic mass.
Okay, so just trying to make this aware that you need to know these well enough because you can easily mess them up come test time if you don't know them well enough. Just by the sheer fact that they all look very similar or have very similar words in them, yes? Okay, yes.
Oh.
Ah. This is yours.
Yeah.
In Jack and H everything that's
No. So I'm gonna have to rewrite that up there. Should I do compounding interest on soda?
after a month is pretty later.
Just bring it
After a month, they have to give me a liter. After 2 months, they gotta bring me a bathtub full of it. After 3 months, a swimming pool full of it. After 4 months, an ocean full of it.
Yeah. Can we just get?
After 5 months,
Just fill up the pool with water. After 5 months,
an infinite. Yeah. They have to drown me in pop. They have to flood the whole earth with pop.
No, fill your
Open
room
the
up with pop.
floodgates.
That would be less than the ocean, though. That's not how
Yeah, but
compounding
this
interest
will be bad. Fill the school with pop.
Just doing what, just like that's break down.
They come and bring a pop at them.
All right, this is a very, very, very high level thing. Not crazy high level, but we're not going to get into how to apply or use the atomic mass. These numbers in the top left corner are the atomic mass, and they have dual meanings. Okay, when you take chemistry, you'll deal with those dual meanings very, very frequently. Okay, I'm just going to explain or like tell you about them. I'm not going any further than that. So here's the definition of what they would call an atomic mass unit. Now notice, it is a unit. It is a mass unit. So it's how you would weigh something. Mass. Okay, it says an atomic mass unit. How they define it, right? An inch is yay long. Yay, whatever. Okay, a meter is yay long, right? That's the standard they chose for a meter. An atomic mass unit, you can't see it. Why can't you see it? This is it's approximately the size of what?
A proton or a neutron.
So if we're talking about a unit that is really, the standard is the size of a proton or a neutron, we're talking about a really small unit, aren't we? Okay? So here's how I define it. The atomic mass, or AMU, is equal to 1/12 of a carbon atom that has 6 protons and 6 neutrons. So what's the mass number of that then? 12. So if you think, if they define it as 1/12 of a 12 mass number, really, the definition of an atomic mass unit is really just the mass of 1 proton or the mass of 1 neutron. Okay? Now notice the electrons aren't taken into account when you do the mass of an atom. Why don't the electrons really have any impact on the mass of the atom? They're so what? What'd you say? Tiny, small. Have you ever tried to add a number like this? 1 plus 0.000001. What do you really get?
1.000.
Yeah, but what is it really still, basically? 1. Okay, remember, the electron is way smaller than the protons and the electrons, so adding the mass of the electrons is probably just going to leave you with the mass of a proton and the neutrons. Does that make sense? Okay? Now, here's where this gets kind of dual meaning here, and I'm not going to get too crazy because we got some more to do, but Okay, this would be the atomic mass of lithium. So generally, if you were to take a general idea, you'd probably say most of lithium atoms have 3 protons and probably 4 neutrons to get you close to 7. But remember, there's isotopes, right? So lithium could have 4, could have 3, could have, you name it, number of neutrons. So this number is actually a weighted average. Okay, that's how your grades in my class work. Okay, your tests are weighted so much more than your homework or your quizzes, right? Okay, remember that nickel example I gave you, and 68% of it was a certain nickel isotope? Okay, I'm guessing that nickel is going to be very much closer to the nickel isotope, which is 58. It's pretty close, isn't it? Now there was other forms, but the nickel 58 isotope was the most prominent. Okay. Now where does the double meaning come in? If I have a really large amount called a mole of these atoms, this number now becomes the same number, but in a unit we understand, grams. So if I have a mole of lithium atoms, it weighs 6.941 grams. Well, a mole is 6.022 times 10 to the 23rd atoms.
That's kind of
A lot of atoms to get a meaningful weight, doesn't it? So, anyways, moving on. Oopsies. Almost done here. Because that periodic table was made in 2001, so they have been discovered just after 2001. Okay, so to define the atomic mass, you really add the number of protons and neutrons in the nucleus, essentially. Okay, now obviously isotopes change things a little bit, but if I were to say that I have the element calcium, it has how many protons?
20.
And let's say I know that it has 24 neutrons. What is its atomic mass?
44.
Approximately 44. Well, for that one element, or one isotope, it would be just 44. Okay? Almost done.
One more.
Oh,
Whoopsies. So this is going into that weighted average thing I was talking about. Okay, if the atom is, the atomic mass is just the number of protons and neutrons in an element, why is it not a whole number on the periodic table? The weighted average. If the elements on the periodic table only had one isotope form, or all had a set number of neutrons, the atomic mass number that's up here on the periodic table would all be perfect whole numbers. But they're not. And the reason why they're not is because of different isotopes having different number of neutrons, so therefore each of the different isotopes have a different what? Different atomic mass, right? If you have a different number of neutrons, it's going to weigh different amounts. Okay, and so they have to take an average of that to get what it would be. Okay, so just saying, if you got 50% A, 20% B, 30% C, you have to take a weighted average. Okay, I'm not gonna get too crazy into this. This is the last one. Let me see if I want you to put this in or not. The value for the mass number and the atomic number are almost the same. Okay, the only reason they're not is because of weighted average of its isotopes. Does that make sense?
Yeah.
Okay. I'll let you decide if you want to put this in or not. You have a question? What's the symbol?
No, it is there.
It's the way.
This is possibly what?
I've read all of this stuff.
Ross, I think first usually
Don't you think what I'm saying?
Even on the
is that
floor.
value?
Second on it.
And writing, but you're not doing it as well. You may be fine at this low of level, but in my harder classes,
Perfect.
No.
Yeah.
Yeah, my dad doesn't want
also, the other classes might be a little more difficult.
Now ours
Yeah.
are like good.
Now artists still like, oh my gosh, I discovered. Yeah, I know, but he doesn't know.
PB, bum bum. B2, I know. Did you get that covered, or did you?
Oh my gosh.
You took me out west?
Have you ever been to
You haven't started yet?
in Iowa? Black circle.
I asked people just like, it's about the meaning. I'm like,
What is no meaning?
There is no meaning.
What is the meaning of life?
To represent